So we want to graph a log, y equals log 4 2x. We realize in exponential form, this is 4y equals 2x. We solve for x, so we have a variable, multiply both sides by 1/2. And we get 1/2 times 4y equals x. I do not know how to graph this, so we graph by inverting the y and x's. So what I'm going to graph, and I'll do it in red, is y equals 1/2 times 4 to the x. This is simply y equals 4 to the x compressed because it's a multiple. So we will graph by moving this to the side. We'll group it. We'll have to put it on a coordinate system. All right? So put it on a coordinate system. We know it's the first coordinate. Make it a little bigger. All right. Actually, if we're going to do the log, I really can't use a first quadrant graph. I'll have to have 4 quadrant graph. I only need to see the first one and a little bit of the second. We'll do this. Make it bigger. We'll put it here. All right. I know very quickly what 4 to the x looks like. It goes through 0, 1, 1, 4. I quickly graph that. I also know that the 1/2 compresses it about the x-axis. So this becomes half, this becomes 8, this becomes 2. And now I have this green curve, which is 1/2 times 4 to the x. We realize that we switch the x and y, thus these are inverses, so we can mirror them across y equals x. So the green point 0, 1/2 becomes 1/2, 0. And the point 2, 1, 2 becomes 2, 1. And there's our curve. And this is y equals log 4 2x. So the second one we want to graph is y equals log 3 number 4x, that quantity minus 2. Again, we're going to have to write this in exponential form, so you have to have log on one side and one term on the other. So I'll send the 2 to the other side and treat that like one thing. So then I can write 3 to the y plus 2 power is equivalent to 4x. I can solve for x by multiplying by the reciprocal. And all of a sudden I have x equals 1/4 times 3 to the y plus 2 power. I can graph now the inverse and I'll start by graphing 3 to the x. All right. The next thing I'll do is I will shift this curve to 2. This shifts it 2 to the left. -2 plus 2 is 0. So this point becomes right there. This point shifts 2 over. If I draw it again, whoops, make the dot a little bigger so it hits. I have 3 to the x plus 2. Finally, the last thing I have to do is the multiplier, which is 1/4 of that. So I'll do that in red. 1/4 of 1 is 1/4. 1/4 of 3 is 3/4. And there is my curve. And I'll just put an arrow to it. And that is 1/4 times 3 to the x plus 2. Now, I can reflect that across y equals x. So my point here, -1, 1, becomes 1, -1. My point, -2/4, becomes 1/4, -2. And if I do this, then, and I can keep on going, I suppose, if I want, -1, 3 becomes 3, -1. Whoops. Or If I plug in 0, I'm sorry, 9 times 4 gets 9 fourths. So 9 fourths. And I'll get a curve that looks like that. And this curve is log 3 to the 4x shifted down to. So the last one I'm going to graph on this video is f of x equals log base 2 number x cubed. Okay, my first step again is to think of this as y equals log 2 x cubed. So 2 to the y power is equivalent to x cubed. If I'm going to solve this for x, I'm going to have to raise both sides to the 1/3 power. Do you guys agree? If I do that, 1/3 and 1/3, I'm going to have 2 to the 1/3 y equals x. Again, I'm going to think of this as y equals 2 to the 1/3 x. I will start by graphing y equals 2 to the x. When you have a multiplier inside with the x, it either stretches it along the x-axis around the y or compresses it. It is a fraction less than 1. It is going to compress these numbers. All right? So it's going to bring these in tighter. So this point will stay the same. And a lot of times students say, like, it's taller. Well, it looks the same as it's getting taller, but we actually smashed it in. Now, we actually have y equals 2 to the 1/3 x done. That is the same as the red function here, except x and y are switched. So now we'll do our reflection across y equals x. And I'll start plotting the points. So I plot 2 1/3, 2/3, 4, and it gets pretty tight to the x-axis here, but there. And now I have the curve y equals log 2x cubed, or I could just label it f of x in this case. Again, graphing logarithms means graphing the exponential and reflecting across y equals x. It takes practice.